So hello friends, today we are here to discuss on a very interesting topic, that is representation of number system or numbers in the computer memory. And also in this video lecture we will be discussing the addition and subtraction of numbers using 1's and 2's complements representation. Okay, so let us first discuss how a number can be represented into the computer memory. So there are three techniques basically. There are three techniques. One is signed magnitude representation, another is 1's complement, another is 2's complement. So let us now first discuss how a number can be represented using signed magnitude representations. Suppose, and as all of you know, a decimal number can be assigned with a sign plus, suppose plus 5 or minus 5, and this symbol, this sign symbol cannot be employed into the memory of the computers. So how you can employ it? By the help of these three techniques. So first come to your signed magnitude representation. Suppose we want to represent the number plus 5 base 10. So and here we are using a 8-bit register. 8-bit register. So first the binary representation, you have to find out the binary representation 5, as all of you know, that is 101. And then take an 8-bit register, okay, 1, 2, 3, 4, 5, 6, 7, 8. And as all of you know, the first bit or the most significant bit of the register is reserved for your sign bit. And here the sign is plus. So instead of plus, it can place 0, right? So 0 indicates the plus sign. And from the right hand side, place the binary equivalent of the number, and the rest of the bits you place it with zeros. So this is what the sign representation of plus 5. Similarly, you can represent minus 5. So the same technique, 1, 2, 3, 4, 5, 6, 7, 8. From the right hand side, you place the binary equivalent of the number, and this is the sign bit of minus 5, okay, and as the minus symbol is there, you can place 1 here, and the rest of the base you assign with zeros, okay. So this is what the sign magnitude representation of minus 5, and this is the sign magnitude representation of plus 5. So clear? So now come to the second technique, that is 1's complement representation. How can you represent a number by using 1's complement representation? And you consider the same register, 8-bit register. And one thing remember, means complementary system can only be employed on the negative numbers only, not on the positive numbers. Suppose same example I am taking, minus 5 base 10. So 1's complement means first you find out the signed representation of sign magnitude representation of minus 5, that is 1, 2, 3, 4, 5, 6, 7, 8. Already we found in the last example 1 from the right hand side, 1, 0, 1, and the rest of the bits you fill it with the 0. So the technique or the process to find out the 1's complement of a number is, first you have to find out the sign magnitude representation of the number, and then you apply the 1's complement technique. And 1's complement technique is what? You simply subtract each digit except the sign bit. The sign bit never be complemented, right? Each digit from 1, or the simple technique is what? You just convert each 0 into 1 and each 1 into zeros. So see, as it is a sign bit, so simply place here the sign bit, and then each 0 will be converted into 1 and each 1 will be converted into 0, or you subtract each bit from 1. So this is what the 1's complement of minus 5. Very simple, right? Now come to the 2's complement. So 2's complement means the same process. In step 1, find out the sign magnitude representation, and step 2 you find out 1's complement, and in step 3 you just simply add 1 with the 1's complement result. So that will be what? Equivalent to 2's complement of the number. So say already we have find out the sign magnitude representation of 5, and already we have find out the 1's complement of -5, and simply you add 1 with the result of 1's complement. Say 0 plus 1 is 1, 1, 0, 1, 1, 1, 1, 1. So this is the 2's complement of -5 base 10. So very simple. Okay. So in this way you can represent a number in the memory of the computer systems. So now let us discuss how you can perform addition and subtraction of numbers using 1's and 2's complements. So let us now discuss how a number can be subtracted and added by using 1's complement representations. So let us take one example. Suppose -5 plus -5 base 10 plus 3 base 10. So in general it will be what? -2 base 10. And see, is it means how can you implement it by using 1's complement? Okay. So this is the rough one. So as first 1's complement, to find out 1's complement, first to store, see, before implementing, your task is first to store -5 and 3 into the memory, right? And as the number is a -5, so you store it, and our concept is it is the 1's complement. So you store the -5 into the memory by using 1's complement form. So as all of you know, and here also suppose we are using 6-bit register. 6-bit register. So first you represent sign magnitude representation of -5 base 10 is 1 for the sign bit, and 101 for the 5, and as you are using 6-bit register, so 100 101, right? And now 1's complement of -5 base 10, so minus symbol, place here the 1, the sign magnitude, okay, sign bit, and all zeros into 1 and 1 into zeros. So 1 1 0 1 0. So you place here 1 1 1 0 1 0. That is what? 1's complement of -5 base 10, right? And the next number is 3. As it is a positive number, so no need of converting into the 1's complement. Simply you find out the sign magnitude representation. Sign magnitude representation of 3 base 10 is what? Your 3 is 1 1, then 0 0 0 1 2 3 4 5, and number 6 bit also, most significant bit also 0, as the number is positive. So you place here 0 0 0 0 1 1. So that is what? The sign magnitude representation of 3 base 10. Okay. Now you perform the simple addition. So 0 1 1 1 1 0 carry 1 1 1 1 1. Okay. See, the result, the most significant of the result, as it is 1, that indicates the result is negative. Okay. So again you find out the 1's complement of the result. This is one rule in 1's complement. So 1's complement of the result. So as it is the sign bit, so you cannot find out the 1's complement of 1 here. So simply place 1 here, and then 0 0 0 1 0. Now this is your final result. This is the final result, and this is what? Sign bit. Okay. So sign bit 1 means what? Negative. So your result, just convert it into the decimal, 2 to the 0, 2 to the 1, 2 to the 2, 3, 4. So this equivalent how much? 2, and sign is minus. So -2 base 10. Very simple, right? So let us take another example. Suppose instead of minus 5 base 10 and 3 base 10, we are taking minus 5 base 10 and minus 3 base 10, and your result will be what? Minus 8 base 10. And same register we are taking here, and see how can you implement it using 1's complements. Okay. So already the previous example we had calculated the 1's complement of minus 5 base 10, and now just find out sign magnitude of minus 3 base 10 equal to, see, 3 is 1 1, then 0 0 0, and the sign bit is 1 as the number is negative, right? And next 1's complement of minus 3 base 10 equal to 1 1 1 1 0 0. So you place here 1 1 1 1 0 0. That is what? 1's complement of minus 3 base 10, right? Then perform the simple addition. 0 1 1 1 1 0 carry 1 1 carry 1 1 carry 1. So see, in 1's complement there is a rule, that is what? If there is a carry, then you simply add it with the result. Okay, add it with the result. See, 0 1 1 1 1 0 1 1. Okay, and the same technique you apply. The most significant bit of the result is 1, that is MSB of the result is 1. So that indicates the number is a negative, the result is a negative. So you find out the 1's complement of the result again equal to 1. So this is the sign bit, cannot be complemented. Then 0 1 0 0 0. So this is now your final result, and this is the sign bit of the result, right? Sign bit. So just simply convert it into its decimal. 2 to the 0 1 2 3 4. So this is what? 8, and this is the sign bit. So minus 8 base 10. Easy. Okay. So I hope you will clear the 1's complement operations. And one thing you remember, there is no subtraction concept in computer system. So if there is a subtraction concept, see, suppose minus 5 base 10 minus 3 base 10. This you can represent in this way: minus 5 base 10 plus minus 3 base 10. So always the computer will perform the addition operation only, right? So now come to the another technique, that is addition and subtraction of numbers using 2's complements. So see, how can we implement the addition and subtraction of numbers using 2's complement? The same register we will be taking here also, 6-bit register, and same example we will be taking here. So it's minus 5 base 10 plus 3 base 10. So here actually it will give you minus 2 base 10. And now let us check whether is it correct or not using 2's complement. So the same way, as minus 5 is a negative number, so you can find out the 2's complement of the 5 only. The same style, the sign magnitude, the sign representation of minus 5 base 10 equal to how much? 1 0 1, the 5 0 0, and the number is negative, so 1. Then 1's complement, as all of you know, 2's complement means what? First you have to find out the sign representation, then 1's complement, and then simply add 1 with the 1's complement, right? So 1's complement equal to 1, the sign bit never be complemented, so 1 1 0 1 0, and then 2's complement of minus 5 base 10 equal to plus 1, simply add plus 1, so 1 1 0 1 1 1, right? So simply place here 1 1 1 0 1 1, and as the next number is plus 3, so only you find out the sign representation of plus 3 base 10. That is what? 3 actual binary conversion is 1 1, and it is a sign, as it is a positive sign number, so 0 0 0, and sign bit is 0. So you place it here 0, 0, 0, 0, 1, 1. Perform the addition. So 1 plus 1, that is what? This is your 2's representation of minus 5 base 10, and this is signed representation of 3 base 10. So 1, 1, 0, carry 1, 1, carry 1, 1, and this is 1, 1, 1. So the same technique, as the MSB of the result contains 1 means it indicates the result is a negative number. So you find out the 2's complement of the result again. So before 2's complement, first you find out 1's complement of the result, that is 1, that is the sign bit, 0, 0, 0, 0, 1, and then 2's complement equal to simply add 1 with the 1's complement. That is what? 0, 1, 1, 0, carry 1, 1, 0, 0, 0, 1. And this is your actual result, and this is the sign bit of the result. This is the sign bit. So just convert it into its decimal. That is 2 to the 0, 1, 2, 3, 4. This is what? 2. So your answer will be minus 2 base 10. Clear? So let us now discuss with another example using 2's complement. Okay? Minus 5 plus 10 plus minus 3 plus 10. And the same register here is you have to use. So that is the sign representation of minus 5 base 10 equal to 1, 0, 0, 1, 0, 1. Okay, already I have calculated. And then 1's complement of minus 5 equal to 1, 1, 1, 0, 1, 0. And then 2's complement of minus 5 equal to, simply add plus 1 here, right? So this is 1, 1, 0, 1, 1, 1. So I simply place here 1, 1, 1, 0, 1, 1. That is what? 2's of minus 5 base 10. Now as 3 is a negative number, so you find out the 2's complement of 3 also. So first you find out signed representation of minus 3, 10 equal to, as binary equivalent is 1, 1, then 0, 0, 0, 1. This is the sign bit, right? Similarly, 1's complement of minus 3 base 10 equal to 1, 1, 1, 1, 0, 0. And 2's complement of simply plus 1 here, it will be 1, 0, 1, 1, 1, 1. See, 1, 1, 1, 1, 0, 1. So this is what? 2's of minus 3 base 10. So perform the simple addition. 1 plus 1, how much? 0, carry 1. 1 plus 1, 0, carry 1. 1 plus 1, 0, carry 1. Triple 1 is 3, that is 1, carry 1. That is 1, carry 1, 1, carry 1, here carry. Okay. And in 2's complement, there is a rule. If there is any carry, then you simply discard it, right? So this is now the result. And again, in the result, the most significant bit is the negative. Most significant bit is 1. That means the result is, or result will be the negative, right? So the same technique, you have to find out the complement of the result again. That is what, as our operation is on the 2's complement, so you have to find out 2's complement of the result. That is, first to find out 1's complement equal to, and this is the sign bit, so simply place here, then 0, 0, 1, 1, 1, and then 2's complement. Okay, so simply add plus 1 here. So that is 1 plus 1, 0, carry 1, 1 plus 1, 0, carry 1, 0, carry 1, 1, 0, 1. Now this is your actual result, and this is what? Sign bit of the result, right? And you simply convert it into decimal, that is 0, 1, 2, 3, 4. Now this is what? 8. So your result will be minus 8 base 10. See? So very simple. So this all about your means addition and subtraction of numbers using 1's and 2's complement, and also in this video lecture we will discuss about what the representation of numbers in the computer memory. So I hope you will be clear all these things. If any doubts, then put a query, and don't forget to give suggestion and comments if any. Thank you to all.